Okay. So locus, the definition of a locus. Now, so locus, so locus is the path followed by a moving point satisfying satisfying set conditions or satisfying some given conditions. Now, so when we apply a conditions to a moving point, okay, and it follows, and the the equation the equation obtained by applying the condition the equations obtained by applying the conditions is called as equation to the locus. So locus is the path followed by a moving point satisfying certain conditions. So an equation to the locus is the equation uh, obtained by applying the given condition. So let's take an example, simplest of example. Uh, P is a point which always moves at a constant distance from a fixed point say h comma k, some c h comma k. Okay, P is a point which always moves at a constant distance from a fixed point h comma k. So c h comma k is a fixed point, and P, now because it's a moving point, we have to write a general equation like this, x comma y. Now, what is the path followed by P? The distance Cp always remains constant. Let's say the distance is r, Cp. Now, P moves in such a way that okay, it forms a circle. I will do this one. Okay. See this. Now P moves in such a way that, yeah, it forms a circle. All right. So this is the locus of the moving point. So P is moving. C is a fixed point and P is moving. But P is moving in such a way that the distance from C is always constant. So locus of P is a circle. The locus, so we say the locus of P is a circle. Now, what will be the equation to the locus? So applying the condition, we get CP is equal to R. CP square is equal to R square. What is CP square? X minus H the whole square plus Y minus K the whole square is equal to R square. Okay. X minus H the whole square plus Y minus K the whole square is equal to R square. This is CP square. Okay. So this forms the equation to the locus. So this is the equation of the locus of P. So an equation like this is an equation of a circle. X minus H whole square plus Y minus K whole square is equal to R square. C H comma K will be the center. And the point moves in such a way that it's always at a constant distance from C. So the path of the point is a circle. Okay, next. So there are many examples like that. This is the basic example. All right. This is another one. Very, very important example. Find the locus of a point which is at equidistance from two fixed points A, say 2, 1 and B 4, 1. Okay. So this is the question. First one was a point which moves such that it is equidistant from one, it's at a constant distance from one fixed point. Now, this is a question in which we have 2 points, 2, 1 and 4, 1. A, B. Now, let us see. Now, P will be any point, let's say, any point for which we have to find the locus. Okay. So let P X, Y be the point for which the locus has to be determined. Okay. Now, given condition is that P is the distance of P from A is same as the distance of P from B. So we can square them to remove the root and then use the distance formula. Now, P is x comma y, A is 2 comma 1, and B is 4 comma 1. So, okay, PA square is x minus x2, x minus 2, the whole square, plus y minus 1, the whole square, is equal to PB square, x minus 4, the whole square, plus y minus 1, the whole square. Now we can simplify this equation. Y minus 1 whole square is on both the sides of the equation. So you can cancel that out because these are equal components. You can cancel that out, both sides. That means then these two are equal. X minus 2 the whole square is equal to x minus 4 the whole square. Why do we cancel out? If we take this to the other side of the equation, it takes a negative sign. So it takes a negative sign. So these two get cancelled. Now let us expand this. X square minus 4x plus 4. And this is x square minus 8x plus 16. So again, x square cancels. Then we have bring this 8x to the left hand side. Minus 8x becomes plus 8x, plus 8x minus 4x is 4x, and 16 minus 4 is 12. So from here we get x is equal to 3. We get x is equal to 3. Okay. So the locus, such a complicated equation, has reduced to this form. Therefore, the locus of P is x equal to 3. And what is x equal to 3? It is a line. This is 1, right? 2, 2 comma 1. This is 4 comma 1. This point B is 4 comma 1. So this is 2, this is 3, this is 4. So x equal to 3 is this line. So, and you can see that it is perpendicular to the line AB. AB is horizontal line and this locus is a perpendicular line. Okay, x equal to 3 line. I will draw a full line. So, and this particular line bisects the join of AB. So there's a very important result here. The locus of a point which is equidistant from two fixed points A and B is the perpendicular bisector. Is the perpendicular bisector of the 2 points of the line joining AB. So it's a perpendicular bisector. Perpendicular bisector of AB. So this is an important side result. So locus is a path. So this path is a perpendicular bisector. So now there are many problems. The textbook has so many problems. They are example problems, and I can give you, first I'll do the exercise problems in the textbooks, and then I will give further problems from little that which requires a little more thought. So let us do something. Yeah, this is from the exercise. I will choose certain problems. Others, you should do it on your own. So let's say question 4. So find the equation of the locus of a point which is equidistant from the coordinate axis. Which is equidistant from the coordinate axis. Do you want to try? You tell me the steps. Now there's a point P. Now this Px comma y can be in any quadrant. It need not be in the first quadrant. Although we are taking it as the first quadrant, it need not be so. Now what will be the distance from the y-axis? And what will be the distance from the x-axis for the point P? Tell me.
From the x-axis, mod y1.
Okay, there is no y1 here. What is there?
Y.
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 Okay. Okay. So let P be Px comma y be any point. If P is equidistant from the x-axis and y-axis, then, so let us say foot of the perpendicular from P onto x-axis is m, foot of the perpendicular from P to the y-axis is n. Then we get Pm is equal to Pn. Now this distance is the y coordinate. This distance is the x coordinate. Of course, if the point lies in the negative quadrants, then this distance distance remains positive, right? So we have to take modulus. So we get mod x, sorry, mod y is equal to mod x. Now mod y equal to mod x, which means either y is equal to x or y will be equal to minus x. That means either both can be positive. So when you remove the mod, so let's say y is equal to 2, then x can also be 2 or x can be minus 2. Or if y is equal to minus 2, x can be minus 2 or 2. So, and what are these lines? Y equal to x and y equal to minus x. Let us see that. These are straight lines. How do they look? So this is the graph. So this is the line y is equal to x. That means, see, on this line, points will be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. So all the points are minus 1, minus 1, minus 2, minus 2, minus 3, minus 3, minus 4, minus 4, minus 5, minus 5. So all the points, x coordinate and y coordinate are the same. All right. And this is the line y is equal to minus x. Okay. So if x is equal to minus 1, y is 1. If x is equal to minus 2, y is equal to 2. When x is equal to minus 3, y is equal to 3. X is equal to minus 4, y is equal to 4. X equal to minus 5, y equal to 5. Vice versa. When x equal to 1, y is minus 1. When x equal to 2, y is minus 2. X equal to 3, y equal to minus 3. X equal to 4, y equal to minus 4. X equal to 5, y equal to minus 1. So this is the line y equal to minus. So what we get, and if we see this angle, if you study carefully in straight lines, when we go into, this angle is 45 degrees. And this angle is also 45 degrees. So what happens for these two lines? This line becomes the angular bisector. So although it is not mentioned here, so the locus of a point this we will study in angular bisectors of straight lines. So locus of a point which moves such that it is equidistant from two fixed lines. Intersecting lines. Locus of a point which moves such that it is equidistant from two fixed intersecting lines is the angular bisector. It is the angular bisector of the two lines. Okay. In this particular case, this problem was very easy. In other ones, we have to use the concept of straight line, but this concept, this is always true. A point which is moving such that it is always equidistant from two fixed lines is the angular bisector of the two lines. It bisects the angle between the two lines. Okay. So this is the angular bisector. Previous one was the perpendicular bisector. Earlier one was the circle. So all the geometrical figures are locus of some condition. So that's what we are learning here. Question 5. Find the locus. Find the locus, equation of the locus of a point equidistant from a 2 comma 0 and the y-axis. So let's do this solution. So this is x-axis, this is y-axis. Now this is a 2 comma 0 and the y-axis. Now the point is such that wherever it is, let p, okay, sometimes we can, instead of directly taking h comma k, x comma y, we can use h comma k. All right, there's another way of doing it. I'm showing that. Now this point is always such that so this is that point P. Now the distance of P from the point is same as the distance of P from the y-axis. So PA, and let's say this is PM. Okay, the distance, no matter, now P can be anywhere, but the distance will be such that it is always equal. So the way to do it is, let P h comma k be the point for which locus has to be determined. Now let P let the perpendicular from P to the y-axis be m. Let the perpendicular from P to the y-axis be m. So, and given and A 2 comma 0. Given condition is that, given condition, PA is equal to PM. Now let us say, what is the, now if P is H comma K, what is this distance MP? What is this distance?
The H.
H, very good. It is H, the X coordinate of P, because this perpendicular, this is X coordinate of P. So it will be H. Okay, you can take modulus also. So PM is H, and PA, we can apply the formula of distance formula. So this implies to remove the square root, we can square PA square is equal to PM square. PA square is H minus 2 the whole square plus K minus 0 the whole square is equal to H mod H square. Now mod H square will be equal to H square. So this is H, right? So H minus 2 whole square is H square minus 4H plus 4 plus K square is equal to H square. I strike this off. H square, H square. Then what I get is K square is equal to 4H minus 4. So I get K square is equal to 4 times H minus 1. So now replace, now H was some point. Now we want to make it as a general point, right? H comma K. Now replace H by X. So X will be a general point and K by Y. Thus, the equation of the locus is K Y square is equal to 4 times X minus 1. So Y square is equal to 4 times X minus 1. This is the equation of the locus. This is your answer. And interestingly, let us plot this graph and see how it looks. I will just use the plotter, but I will also show how to plot it later. I want to show the point. Yeah, 2. So this is a curve like this. This curve has a name. This is called as a parabola, which you will be learning in the second year or class 12th. This is a parabola, one type of a parabola. Now, so locus of a point which is equidistant, whose distance from a fixed point is equal to its distance from a fixed line. That is called as a parabola. So here, if I trace this point, so this 1 comma 0 will be a point which is equidistant from A and the y-axis. And similarly, there will be another point here, which is equidistant from A and the y-axis. So if we plot the curve will be like this. Okay, that's the parabola. So the point moves in such a way that it satisfies this condition. Okay. So of course, for you at this level, you need not, of course, knowing this geometrical conditions are very good. It is very useful, extremely useful. But for you, how to write the equation is more important. All right. Now in the second part of the exercise, there are some important questions. Find the equation of the locus of P if the line segment joining 2, 3 and -1, 5 subtends a right angle. Can you tell me what is this locus just by seeing the question without even solving? Any of you?
Form a right angle triangle.
And it's a moving point. So from your class 10th geometry results, can you tell what will this point be?
Pythagoras theorem we have to apply here.
Yes, but we'll use Pythagoras theorem to get it. But what will you get? What will be the locus look like? In geometry, okay. Oh. Now in geometry, which angle does a diameter subtend on the circumference of a circle? What does a diameter subtend, which angle on the circumference of a circle? Do you remember?
180.
Hmm?
180.
Pardon? Loudly.
180 degrees.
No, how can it be 180 degrees? Diameter is a straight line. Diameter is a straight line. This chord, have you done this in minor segment, major segment of a circle? Okay, this is a circle. Suppose this is a chord of a circle. What angle will the chord subtend on the minor segment? On the minor segment, just a second. There's a chord AB. Now, in the minor segment, this is the smaller portion. The chord divides the circle into two segments. The smaller segment is called as the minor segment. In the minor segment, the chord AB subtends what angle? It is an obtuse angle. Okay. And on the same, on the major segment, the chord, the same chord at any point on the major segment, okay, the chord will subtend an acute angle. This angle will be acute angle. What is an acute angle? Less than 90 degrees.
90.
Obtuse angle greater than 90 degrees. Now what I do, I keep moving. I'll erase this one. That will make sense. Now, I will keep moving this AB towards the center. All right. So this angle will become smaller, smaller. This angle will become larger and larger. Correct? Now, when AB comes exactly diameter as a diameter, it passes through the center. Then what happens? What will this angle be? What will this angle be?
90 degrees.
Very good. Very good. So diameter subtends 90 degrees angle on the uh, on the circle at any point on the circle, at any point on the circle, no matter which point it is, it subtends a 90-degree angle. So there's a geometric property. So now my question is, here, find the equation of the locus of P if the line segments joining 2, 3 and 1 minus 1, 5 subtends a right angle at P. This will be a circle. The locus of this will be a circle whose diameter is the line joining the 2 points AB. We will see that. I will show that. This will be a circle, but let us do the calculation. So here we'll do. So these are side, this is side point. I will mark this as a side point. This is side point. Okay. Now let P H comma K be the point. Let P H comma K be the point for which equation of the locus of P has to be determined. So let A be 2 comma 3, the given point, and B be minus 1 comma 5. So now given that AP is perpendicular to BP, that is angle APB is 90 degrees. Therefore, ABP forms a triangle right angled at A. Okay. Therefore, so we'll have to apply Pythagoras theorem. So if this is right angle, AB will become the hypotenuse. AP will be one side, PB will be another side. So using Pythagoras theorem, so using Pythagoras theorem, AB square is equal to PA square plus PB square. So A is 2 comma 3, B is minus 1 comma 5, and P is H comma K. Later on, we can replace H comma K by X comma Y to generalize. So AB square is 2 minus of minus 1 the whole square plus 3 minus 5 the whole square is equal to H minus 2 the whole square plus K minus 3 the whole square. This is PA square plus PB square, H minus of minus 1, that is H plus 1 the whole square plus K minus 5 the whole square. Now let us simplify. Left hand side is 3 square plus 2 square. And here we can expand this. H square minus 4H plus 4 plus K square minus 6K plus 9 plus H square plus 2H plus 1 plus K square minus 10K plus 25. Now 9 here cancels, 4 and 4 cancels here. Now H square plus H square is 2H square, K square plus K square 2K square. Now minus 4H plus 2H is minus 2H, minus 6K minus 10K is minus 16K. Plus 1 plus 25 is 26. Now we can divide this by 2 throughout. H square plus K square, 2 is the common factor, minus H minus 8K plus 13 equal to 0. Therefore, equation of the locus is replace h by x and k by y. So x square plus y square minus x minus 8y plus 13 equal to 0. This is the answer. And this you will learn in the second year is the equation of a circle. This is an equation of a circle. Got it? I can plot this, but I will show you here. Let me see if I'll be able to demonstrate. Hmm. Circle center radius compass. The 2 points we have are -1, 5. Oh, the 2 points are -1, 5. Yeah. And 2, 3. Right? 2, 3. 2, 3. Now I draw a line segment. Okay. Now I have to draw a circle. All right, midpoint. Point which makes an angle. Let us. Okay, I'll draw a circle only. Circle. No, no. This doesn't give how to make with a diameter. Otherwise, I would have constructed. So midpoint of this is -1 plus 2 by 2, that is 0.5. 5 plus 3, 8 by 2 is 4. So midpoint, we'll mark the midpoint. Yeah, it is 0.5. Edit. The point is changing. When it comes to midpoint, I will change. I'll stop. I'm not able to edit. So anyway, this is close enough. Now I'll draw this the center radius form. There's a circle. So now any point any point P on the circle will subtend a 90 degrees angle. You can check this. Angle A D B 90 degrees. Of course, little error is there, but um, because the center is slightly off, if the center were center were to change, the point will change. 1, 2, 3, 4, 5, 6. All right. Okay, I can fix the point C. Point 5, 0.5, comma 4 is point C. Okay. And I draw. All right. Again, it has come back. Anyway, I'll leave it here. So uh, we can show that these angles are always 90 degrees, no matter where. If D changes its location, also it will be 90 degrees. All right, I'll end the class today here. Equation, you please solve questions from the textbook. If there are any difficulties, you let me know. In the next class, I will give objective type questions on locus. All right, we did 4 problems today on locus. Do you have any questions?